Okay, welcome everyone to ACDE 158. Couple things today. Quickly, we'll go over Shanghai and that, which is planned in the next 2 weeks. But then most of the call, we got some big updates on pretty much all the largest potential EIPs for Cancun, so we can go over those. And if there's anything else people want to bring up, we can do that at the end. I guess to start, so we announced Chapella earlier this week. I linked the blog post in the agenda. I can put it here in the chat as well. And I think Aragon is the only client for whom the version has changed since the original announcement. So if you had originally downloaded version 2.41, you now need to change to 2.42. Otherwise, everything that was originally listed is still valid. Anyone from any client teams or testing or whatnot have any updates or thoughts they want to share on the announcement or their client release?
Prism is thinking about another minor release probably sometime next week to fix some API RPC issue. This is our slightly optional unless you're like this operator, you are pulling this API, then you probably don't need to update. But yeah, anyway, watch out for our announcement.
Okay. Anyone else?
Yeah, we started doing some EVM fuzzing for Shanghai, and I have not looked at the results yet, but I'm currently doing it with Geth, Besu, and Nethermind, and I'm going to add Aragon and Nimbus EL to it as well.
Cool. Anyone else have anything they want to share about releases or upgrades?
We have the last shadow fork planned for next week. It'll go through the transition either Tuesday or Wednesday, and the idea is that relays are up and running then, and we can test the transition with relays. If someone wants to test a release they're planning to have in the next couple of weeks, let me know. Otherwise, I'm just going to use the recommended releases.
Got it. Anything else?
Lodestar has 1.7.1 out. It's a minor update for people using Goerli for testing with Lodestar. We may also do a minor bump with a fix for our BLS pool, but that's it. Keep an eye out for that.
Okay, but the 1.7.0 is still correct if people just want to keep that, correct?
Correct. Yeah, that'll still work.
Okay. Anything else?
Maybe a small reminder related to the EIBs. So now Chapella upgrade is in public testnet, and obviously we do have the mainnet date announced. So ideally we should have all the proposals which are going to be deployed on mainnet in the last call. So this reminder is for the authors for proposals 3855, 3860, and 4895. Please go ahead and create a pull request to move the proposal to the last call ending on April 12th. Yeah, please reach out to ECH if you want us to create a pull request and you are okay approving it. Otherwise, yeah, do let us know if there is anything we can do for that.
Okay. Anything else? If not, just as a reminder, so the fork is scheduled for April 12th at 10:27 p.m. UTC. That's epoch 194048. So please upgrade your node before that. And for all the validators, we have a withdrawals FAQ that's linked in the announcement that you should check out to make sure you're properly ready for withdrawals. And then similarly, Alex, you made a small update to the withdrawals EIPs for 895 just to add the actual timestamp of the fork into the EIP. Anything else to add on that?
No, that was it. It was just TBD, and so I just put in the mainnet timestamp.
Cool. Anything else on Chapella? Okay. So for Cancun, we have updates on EOF, Selfdestruct, the beacon state route, and the engine API. So we can go through each of those. Starting with EOF, last week or this week, there was the mega EOF endgame spec that was put together. I don't know, Alex, Pavel, do either of you want to give context on that and kind of share the latest on EOF?
Yeah, absolutely. You can hear me correctly, right?
Yeah.
So just like a bit of background, VTOF, we had a fairly stable version, last December, and then we had this proposal to avoid code introspection, and may also potentially avoid like gas inspection capabilities. And so basically, we have worked since then. The work mostly started at Edelweiss to redesign EOF in order to support these requirements. And also, meanwhile, a number of smaller requirements arose. And so basically, over the past like 2 months, we have been working on fleshing out these questions. And we took the unified spec, which many of you may be familiar with, and we made the changes to the unified spec in order to support these requirements. I also have like a gist with the diff between the two, and the diff actually isn't that big. I think it's around like 200 lines. Just to show that, this may look like a lot of features or a lot of new things compared to last time, but actually the diff isn't that significant. I think the biggest, so the requirements we had is to avoid code inspection, and I think we successfully accomplished supporting that requirement. What that means is that creation has to change significantly. And it also means that we want to remove operations like code copy and Xcode copy. And we figured out a way how to deal with Xcode copy, especially for the direction of going from legacy accounts to EOF accounts. It's described in the document what should happen in that case. And beyond that, the create instructions and the create transactions are the biggest changes. So what we came up with is actually not that far away from the initial proposals back in, I think, end of December or early January. I would say it's a refined version of that. We have two create instructions. The first one is create tree, which takes a index for a sub UF container, and this sub UF container would be part of the creator contract. And the sub UF container is the runtime piece. So this create tree instruction can be deploy time validated that it has a correct payload for the runtime. And then it's described how the creation process works. It's not really any different to how it works in legacy. The main important difference is that we only have create to style creation, which uses a code hash, and we don't really have a need for a nonce. And then the create for instruction is a bit more interesting because with this create tree, you can imagine that somehow this runtime payload has to, this init code has to enter the system. And there we have two options. We can either create a specific create transaction, or we can introduce this create for instruction, which works a bit differently. So what we do is instead of having a specific create transaction, we only extend the basic transaction format. And in fact, we only want to extend the 4844 transaction format with the new field, which is a list of init containers. And this list of init containers can only be inspected through the create for instruction. So the create for instruction either takes the index in this init container list, or it could take, this is the only question we haven't settled on yet. It could take the hash of an entry. And that's the only way to inspect this data. And at runtime, this data is validated to be correct UF. And then the creation process is the same as it is in create tree. So that's the only difference between the two. There's also an interesting side effect of this. We could have basically a creator contract or even a creator precompile. But when I say precompile here, it's actually not. It doesn't need to be written in as a precompile. It only means that having this EVM code at a known address. There's an example what such a creator contract would look like at the end of the document. And it basically would take the index of this init code list in the transaction and some additional data as the input, would perform the creation and return the address. The interesting effect here is that if we do have such a creator contract, and then instead of having a create transaction, one can just send a regular transaction to this creator contract in order to deploy code. And then the rest of the additions is instead of the return instruction returning the payload, we have a return contract because that only has an auxiliary data which is appended to the runtime payload. The only reason we need this append option is to support this feature of solidity of immutables. This feature in solidity is basically you have two options today on legacy code how to access data. You could just create storage slots, or if you don't want to spend all that gas on S loads, you can use this immutable feature in Solidity, which basically translates into appending constant data at creation time and then code copying those data sections instead of S load. So return contract is not returning the entire payload. It is only returning a payload which is appended to the runtime container. So that is the only piece which can be inspected. And since we don't have Xcode copy or code copy, if we do want to support this immutable feature, we need a way to inspect the data section. And for that, we have a number of instructions, such as data size, data copy, and data load. And there's a one specific instruction called data load n, which instead of taking a stack item for the offset in the data section, it takes it as an immutable, as an immediate. And the main benefit of this is this basically replaces, this could be used instead of pushing constants in Solidity. You could just data load from the data section where the constant is something like an immutable. So this piece is really just an optimization, this data load n instruction. But the other instructions would be needed to, perform this feature set. There are a number of other like smaller changes, but I think this would be the important ones. And maybe I would close out with saying that every other question which was an open question during earlier discussions in December and January, and anything which has been brought up by the community has been addressed at the specification. And then lastly, beyond the specification, we have a implementation of each of these features in EVM1, and we are in the process of creating state tests for them. Yeah, sorry, this was a super long
thank you.
intro.
This
I didn't expect.
Yeah, does anyone have thoughts, questions?
Yeah, I think it's great, but I worry that if we try to deliver it in Cancun, it's too big a change. So I would definitely want to have it in Prague, but I just think Cancun is stretching it.
Got it. Thanks. Any other thoughts, either on like the spec itself or like overall timing? Okay, I guess where's the best?
I have a question.
Please, yeah.
Sorry.
No, go ahead.
One of the design decisions calls for adding a field into the transaction. I'm interested to solicit the opinions of the other core devs of their appetite for that addition. Does it feel good, feel bad, great, awesome? Some sort of a signal as if whether or not this is the right direction they would expect a transaction like this to move in.
Oh, sorry, I lost audio for a sec, Dano. I don't know if anyone answered to you.
No one answered, no one raised hands. So there's no concerns with adding an extra field into one of the new transaction objects to handle the new create approach.
I do have concerns. One concern is that I didn't really fully understand the proposal yet, so I cannot really comment on it. So, like, not raising concerns right now doesn't mean that I might not have concerns in the future. So we shouldn't take, like, not saying anything as no concerns by default.
That's fair. But I do want to bring that to people's attention to please read it, and not just wait until 2 weeks before we're supposed to ship it on the testnet.
Yeah, and there's some comments in the chat about basically Vercol being another thing we want to do, after Cancun, and obviously, if we push EOF out of Cancun and potentially do it in the fork after, that also means we might push something like Vercol out of the fork after, do it in the fork after that. Potentially we could do them together, but that risks being a lot of big changes at once. Yeah. I guess where's the best place? Clearly, like, I think teams probably need some time to look into this more and kind of digest it. Where's the best place to share feedback, comments, questions?
There is an EVM channel in the Ethereum R&D Discord. Everyone who's implementing it is there. We also have an EVM implementers call on the Wednesdays that are not EL. So it's the day before the consensus call. Calling into that call, it's about the same time, just on the day before, is an excellent time to come in and drill down with your questions and seek understanding.
Okay, Alex.
Yeah, so generally we had a number of different options, had to split up. Because you may remember in January I said that I felt like doing all of this at once maybe quite big. I tend to think now that the change set isn't actually that big as I expected in January. That being said, it is possible to break it up by skipping some of the create features and rolling out, like for example, skipping create 4, or skipping even create 3 and having a intermediate step where legacy creates EOF code. We did review these options, and they are feasible. So it would be possible to also launch this in 2 pieces. But if we postpone all of these, I would still favor that we introduce at least the transaction field together with 4844, and just it would be a field which cannot be really used, but you would still pay the gas for it. Because that way we can avoid like the proliferation of new transaction types.
Any thoughts on that? Okay, so I guess let's. Oh, Edgar, sorry. Yeah.
Yeah, I would just very briefly want to say that my intuition would be that if we end up not bundling full EOF with 4844, though, that I'm not very opinionated on the specifics. Can we have some small pins already in that 4844 fork still? But what I would say is that probably it would be better to then just give EOF its own fork afterwards, in between, like before the vertical fork, and just try to make it like a quick follow fork. Because if we keep basically trying to bundle it with another big change, but then we keep prioritizing the other big change over EOF, we will just keep pushing it. So I feel like if we don't end up combining it with 4844, it should really get its own fork afterwards.
Got it. I think in theory, I also agree, but one risk, like, well, I don't know if it's a risk, but like there will be other stuff that people want to do at the same time as this EOF fork. So we're just saying like, the next fork is EOF. And maybe there's not like CL changes that come in at the same time, but I think, there is some overhead to like having these forks. We can try to keep it minimal and not have too many other things, but we don't sort of get a fork between EOF and or between like Cancun and Prague for free, right? Like it just means we prioritize EOF before whatever we would have done next, which is fine, but yeah, I think realistically you end up with like there will be other things that will be included along that, and it's another like I don't know 3 at least, if not 4, 5, 6 months to put out a fork generally. But yeah. So basically, yeah, EOF would be the big thing if that fork. Yeah. Lucas?
Yes, so we were actually discussing it internally in Nethermind, and what looks sensible to us is not doing EOF in Cancun, but schedule another fork for that. That would the driving force of that fork will be EOF and SSDification. So that was like that looks sensible to us, right? And then on the next for example, if the vertical trees will be going in, that would be for the vertical trees or something else. But I think those two things are big enough to themselves that they, we want to do them, they occupy like most of the fork if we want to do them fairly soon after Cancun.
Got it. Thanks. Guillaume?
Yeah, I'm missing the part where EOF is more advanced than Verkle and therefore should be scheduled first. I really don't see. I mean, maybe I get the wrong impression, but yeah, I don't want to push Verkle again when it's way more ready than other things. EOF. I mean, if EOF needs more time, I don't see the point in delaying Verkle. Is what I'm saying, and what I'd like to understand why this is not obvious to everybody here.
So there's a comment about EOF being much more ready than Verkle. Does it make sense that maybe, I don't know if on this call you have it here ready, or maybe on the next call give a proper update on Verkle trees so that people can understand where it's at?
Sure, I can do that. I mean, I can even do that now if you want.
Okay. Can we wrap up EOF first, and then we can definitely do Verkle today as well. But just want to make sure we wrap up EOF. Yeah.
No, but I mean, if you have an agenda, let's do it next time. No problem.
Yeah. Okay. Yeah. So yeah, if there's time today, let's do it today. But we can do it next time for sure. Yeah. Ansgar?
Yeah. I don't want to say anything about whether Verkle EOF is closer to ready, but what I would say is that actually it seems like bundling them would really not make sense, right? Because they're both very heavy EL side changes. So I feel like if we are bundling something, then it should be EOF and 4844 for Cancun. But if that doesn't happen, we should definitely have them in separate forks, because that would just be a big mess, in my opinion.
Andrew, yes.
I'd like to say, like, I'm totally for Verkle, but I suspect that that actually switching to Verkle, it's a huge, massive change on the L side, and it will take other teams a lot of time to be, in terms of the engineering, to be ready for Verkle. So I kind of urge everybody to start looking at Verkle and doing the necessary engineering work. And it took Aragon like years to change the data model. So it's a big and long change. So I'm just thinking that realistic. I'd love to be wrong, but I think realistically it will take a lot of time just on the engineering front to be ready to switch to Verkle.
Got it. Okay, so let's make sure to cover, if we have time today, we can do more Verkle, but otherwise next call, let's make sure to go over it and get like an update from Guillaume and the different kind of teams. Any other thoughts on EOF specifically? Okay. In that case, next up, we also have an update on Selfdestruct. So Guillaume, Vitalik, and Dankrad have put together a spec for the basically Selfdestruct, but allow it if it's called in the same transaction as a contract creation, which addresses a bunch of the edge cases we've discussed previously. Yeah. Guillaume, Dankrad, do either of you want to give an update on that? Dankrad, you're completely breaking up.
Sure. So,
Oh. Yeah, we can't hear you super well.
Is this better?
Yeah, much better.
Okay, so basically it's a new version of deactivating self-destruct. We've had a few iterations. So this one, what it does is it mostly works just like the complete deactivation, which just makes it basically only send all the funds. Except in the case where it's called in the same transaction where a contract was created, in which it, in which case it will clear all the storage and everything about the contract. So like it will be from the EVM side point of view, actually at least
it will behave exactly like the current self-destruct. You cannot detect that there was any contract deployed at that address. And so the reason why we suggest this is that at least for one of the examples we know that has like at least some amount of TVL in it, which is the Spine Finance contract, that would solve their problem. Because what they basically do is they use self-destruct to limit who can call that contract. Basically, they have a contract that anyone can call, but because it only lasts at that address for the duration of a transaction and is then self-destroyed, nobody else can ever actually call it. So it's basically using this pattern for access control, and yeah, so that kind of functionality would be unaffected by this change. And the reason for this is that basically we have had the different versions, and all of them we ran into like either a security problem, which is the one where we don't clear the storage, which was suggested previously, or like the other possibility would be, of course, to have like fully functional self-construct where we show contract versioning by having this reincarnation count. I think that would be, from what I've heard, significantly more complex to implement. I think Guillaume had a go at it. Basically, it at least for gas, it seems to reach a solution that hopefully doesn't break.
Thank you. Okay, there's a first question in the chat, and then we can do Andrew. But there's a question from Dano about if there's pending storage rights in the destructed contract, will those storage rights be persisted as part of the contract finalization?
Sorry, what is the pending storage right?
So if you're doing a self-destruct in a contract that exists, and before you did the self-destruct, you wrote to one of the storage slots, do those storage slots get committed before the contract is marked as self-destructed?
No, like the storage will be empty. So like what the client will have to do is have to track all the rights that the contract does, and if it does get self-destructed in that transaction, then the rights will not actually be.
But this is the case where it's not the same transaction, where it's an existing contract, and they, in the logic in their code, write some stuff to storage.
Okay, I would assume that in that case, because at least the way it's specified right now,
it's not clear the way it's specified right now.
That I would say it is, but we can happily add another bullet point to clarify this detail.
Right. Either way is fine. I just think it should be clarified.
Yeah. Okay, sure. Yeah, feel free to like add a bullet point on that.
Cool. Andrew?
Yeah, I think this version, it hits the sweet spot between reducing complexity and not breaking too many things. So I think it's it's a great option, and I would CFI it for Cancun.
Got it. And do we know, on your second point about not breaking too many things, does anyone know like if and what would break based on this? I know we've done a bunch of analyses, but I don't know if we've had one where like we specifically look at like, you know, how much, like what would potentially break from this. So I'll take this as a no.
Yeah, sorry. If I'm only aware of 2 contracts that would be broken by just the simple removal of self-destruct, and this fixes their problem. So if we need a new analysis to make sure this solution fixes it all. But as far as I can tell, it's the good enough solution. No one else has come up saying this is not good enough for me so far.
Okay, so and there were 2 people at least who asked about making this CFI'd. I feel like what might make sense is to actually make this CFI'd for Cancun to sort of signal that it's happening, and then in parallel to that to, you know, run like a more thorough scan on the chain, with this, potentially with like, a prototype client implementation, and try to analyze, if anything breaks that, we did not expect. But I think just, to signal that this is happening to the community, and that if somebody's application or contract is affected by it, they might reach out. I think CFI will help with that. Does anyone disagree with that? Okay. So I'll make that change after the call. So yeah, the EIP number is 6780. If people want to review this, and if you are listening and are potentially affected by this, please have a look to make sure that you can raise an issue with us. Anything else on self-destruct? Okay. Next up, Alex, you wanted to talk about giving access to the consensus layer state root on the EVM. You wrote a little doc giving some context, but please walk us through it.
Sure, yeah. So the doc Tim dropped in the chat is here, and basically is like just written form of what I'm about to say. But essentially, I just wanted to get some opinions on a path forward for verifying SSZ proofs. So there's like kind of two big pieces to this. And the first piece is having some accumulator from the consensus layer in the execution layer. So the way we usually think about this is having like the state root or the block root for each block or state. Have some opcode or something that exposes that into the EVM, and then you have this thing that you can make proofs against. That's generally the approach of EIP 4788. So the thing is, though, there's one other thing, which is that the way SSZ works is that you basically have these things called generalized indices. And basically, they're just like pointers into this whole like Merkle tree structure that you need. The problem is that they theoretically can change. And so now the question is like, how do users of the system deal with that change? The straightforward answer is like the protocol gives them nothing and they just have some governance. But, if you're like a staking pool using this stuff, that's not ideal because now you need some like governance answer to like change this technical thing. And, one other option that gets around this is just having, say, a precompile for these things that can be updated, as we need it to be. And then essentially it becomes, you can imagine there's like immutable, contracts using this stuff because, they just have the changing state behind the precompile. So I think for now, my question is first, does anyone have any takes on this problem? And like in particular, does it make sense to maybe add a new precompile for this generalized index thing? We can instead, so the way we have it right now is with the EIP 4788, that would expose the root, and then you could imagine a different precompile for this generalized index accessor, let's call it. The question is like, do we want to have two precompiles for this? We could imagine fusing them and just have like a generic SSZ proof verification thing that does it all. Or maybe some other option. So I wanted to bring this to the floor, and I wonder if anyone has any thoughts on that.
Anyone?
Do we understand the problem?
Yeah. Decrad, yeah.
Yeah, I would generally be for having some way of getting generalized indices inside the protocol just to avoid the upgrade problem. But yeah, I mean, it's not going to be there. There's not going to be a super elegant solution because it also changes, right? So the precompile will at least have to also take fork versions and I don't know what else to like know for each specific state route how to interpret it.
Okay. Any other thoughts?
Yeah, I'll take this for now as just evidence that no one has any particular preference. And yeah, sometime later, maybe the next Valcore devs or the one after that, I'll have some updates for 4788. And maybe I'll also have another EIP for some precompile here for generalized indices.
Cool. Sounds good. Next up, Mikhail, you wanted to talk about get payload v3 with the builder override flag.
Yeah, thanks. So the if I understand correctly, during one of the previous calls, there was a kind of rough consensus to have this feature of builder override flag, and there was an agreement that we want to implement heuristics on the EL side, and it will suggest CL to switch to local execution to block obtained from local execution engine rather than like go into builders and get a block from there if we see some censorship is happening. So I mean, like, there is a rough consensus that we want this feature, and this proposal is in the field of when do we want it to be implemented. So this particular proposal creates like a separate document and makes it in a way that makes the specification in a way that it can be implemented separately from the next fork. So right after Shanghai, for instance. Yeah, and the main question here is that if there is anyone from EL client teams who wants to really work on it right after Shanghai and before Cancun, then it does make sense to spec it out separately and yeah, do it this way. If yeah, when I'm talking like work on this, it implies that really work on heuristics and really make this feature enabled, not only change the format of the response of the get payload and stub out this for the next update with the real heuristics. So, and the other option is that nobody is willing to work on it before, say, before Cancun. Then it would make sense to not do it separately and just spec it out as a part of Cancun specification. So that's the kind of main question. And this proposal suggests that, right, we will do it right after Shanghai before Cancun. I just wanted to bring this to everyone's attention, and if there are any opinions right now, so from EL client developers mostly, well, it'd be great to hear them.
I think it'd be nice to have this functionality for the reasons you gave. And if it's as simple as just adding this extra Boolean field, that should be pretty straightforward. And yeah, that being said, we don't want to, I think, block Shanghai for that change. So pulling it out into like a separate stream makes a lot of sense.
And I assume
yeah, but probably, sorry, go ahead.
I was just going to ask, is this something that all the clients need to have implemented at the same time? I assume not, right? Like,
no, it's not really. So we can do it really in uncoordinated fashion.
Yeah.
But if nobody will really implement heuristics for censorship that POTOS has outlined, or maybe some else algorithms before Cancun, yeah, it doesn't make sense, you know, to spec it out like separately. Yeah, I mean, like Prism will do it. I'm pretty sure, but we need some EL clients to kind of say that, yes, we are willing to work on it as soon as possible. And then it makes sense, I mean, like to merge
I
this
missed
proposal.
the beginning. So why do we need the CLs to do anything? I mean, for the CLs, the change is absolutely trivial, right? We either accept the recommendation or we don't.
Yep.
So for us, it's just a one-liner. And for the ELs, well, it depends on how much of our heuristics they want to add.
I mean, it's probably more than just one line, but either way, you know, one thing you could do is work with, like, say, Gath if you want to write Go and like prototype it out, just like bid out the idea, you know.
Yeah, so already Marius put up a couple of PRs with a proof of concept for one of the two heuristics, which is forking censorship. So, and it doesn't seem to be such a large line count at least.
Yeah, I would have to look into like who does what and who can potentially help her, but I think Nevermind can also do it. Like I mentioned on some other call, I'm like a bit not sure about like coming up with proper heuristics, but I see that there are some already.
So I actually think that the EL devs coming up with their own heuristics is really good because we don't really want everyone to like if I don't know if the heuristic can be attacked, we don't want everyone to stop doing math stuff at the same time. So I think if we all come up with our own mechanisms, then it's a kind of client diversity improvement.
I laid out 2 or 3 heuristics that seem very simple in the issue or in the PR, which is just tell us if transactions are being reorged consistently, if blocks are being invalid when they include particular transactions, or if transactions are being delayed consistently. It'd be nice if someone comes up with something better to add it to that PR or to add it to that description. I can't think of more that I would like to see, and all of them seem to be easily implementable. I'm actually willing to write the PRs if the ELs go ahead and put up the Boolean in the get payload. I can actually try to help them writing some PRs for some ELs if there's, I mean, lack of people writing this.
So Nevermind, we'll pick it up and we'll prototype something.
Cool. It would be great if like we can definitely can't decide something right away, right here on the call. So it would be great if just EL client developers look into it and then we come to some consensus that 1 or 2 teams are willing to work on it before Cancun and have enough capacity to do that. So in one of the next calls. So yeah, doing some prototyping may really help to answer this question, whether it's difficult or not.
And I guess, yeah, if we can have one client at least show that like on the EL side, they can implement something before Cancun, then it makes sense to spec it independently of the fork. But then if no one sort of has the bandwidth, maybe we bundle it with Cancun. Is that what you're saying?
Yep, yeah, exactly that.
Okay.
Wait, so are we talking about speccing the actual heuristics, or just the specification is going to be just include the Boolean?
I'm talking about the specification includes the Boolean, because if it doesn't make sense to just add this Boolean to the specification if no one will really effectively use it.
Oh, I see. So you want just consensus that someone will write some non-trivial heuristic, and that's going to be good enough to specify the Boolean. What's going to be specified is only the Boolean, right?
Yeah, definitely. I mean, like, I'm trying to understand whether it makes sense to specify these booleans separately from Cancun. That's the main
perfect.
question.
That makes a lot of sense to me. Thanks.
Yeah. Does anyone disagree with that? Okay, so yeah, let's do that. Obviously, we can keep this PR open, yeah, as we have more EL clients implement things, if that happens before Cancun, we can just merge it in, and otherwise we'll add it as part of the Cancun specs. Okay, so that got us through all the stuff we had on the agenda today. We can discuss Verkle in more depth, Guillaume, if you want to give an update now.
Sure. Yeah, so I mean, Verkle's been going along fine. There's been 2 testnet that were produced. One of them is called Beverly Hills, and this one is closer to what, well, hopefully Prague would be, which is just using a Verkle tree without producing the proofs. So on this type of network, you don't need to have any work for like on the CL side. So that would be a fork that would not require any change on the CL side. And then there's another testnet called Kaustinen, which this one uses like adds the proofs to the execution payload or execution data. So this one is also working. Nethermind has just joined the two testnets last week. I mean, the last one was today, but Kaustinen was today, but Beverly Hills was last week or 2 weeks ago. And yeah, there's been some progress in the performance as well. I think we're only currently 40% slower than regular MPT. And yeah, we still have a few things in the pipe. So I'm not saying it's ready to ship in Cancun, but I still get the impression, at least the spec has been stable. Transition is okay, still an open question, but yeah, I don't really want to share stuff about the transition because it's improving greatly in great strides at the moment. So I hope to share something about this soon, but I don't see why it would not be ready for another, like for the next fork after Cancun. Excuse me, simply because yeah, I think like most of the questions have been answered over the last 2 years, and it's just a matter of implementing. So I understand that for Aragon, the database model is a bit more complicated, but I would say the real problem is that people don't look into it. But Nethermind has implemented it in less than a year, so I think at this point it's quite clear it's looking realistic to be shipped in Prague. And yeah, I don't know if there are questions about the current status, but overall, I think it's getting close to ready.
I have 7 questions already.
Okay,
amazing.
Go ahead.
Okay, so have you tested the implementations against reorgs?
Against reorgs? Yes.
Okay. JSON RPC, does have any degradation in like ETH call, things like that?
Right. So okay, JSON RPC hasn't been tested.
Okay. Have you tested mainnet?
Not
mainnet?
totally.
Okay, mainnet like blocks.
Yes.
Have you managed to do a mainnet shadow fork?
Right. So this is the problem. I mean, but when you're doing a mainnet shadow fork, you're pretty close to the end. It's yeah, okay. There's a new decision that has been okay. There's a new design that had just been decided yesterday. So no, it hasn't been done, but it will be done this month.
Sorry. Multiple client transitions. So be good to have more than one client doing the transition, right? Generating, for
Yeah.
example, the transition, or is it fine to just have one client do that?
No. Yeah, we should have that. Agreed. Yeah.
Okay, that will take a long time, so it's good to like maybe work on it earlier in parallel, but just highlighting problems. And last one, and that is a big one, SnapSync for vertical trees.
No, yeah, there wouldn't be any SnapSync for vertical trees. Yeah, it would be a vertical sync.
Okay, how would it perform compared to SnapSync?
I mean, yeah. I mean, presumably better, but yes, we don't know until we have tried it. Yeah.
Okay, so quite a few question marks, right? So
no, okay, yes, I'm not like I said it's not ready.
Yeah,
I mean,
agree.
I
I
said
agree.
it's getting closer to being ready. I said it's definitely not ready, like it can be shipped in Cancun.
No. Don't worry. I'm probing. I'm probing where we are, right, on the
yeah,
decision
okay.
when to ship it, right? And
Right.
yeah, I still think it's far away. It's a lot closer than it was like a few months ago, and so yeah, I'm reluctant to rush it, right, until those questions we have answers and we are happy with those answers for those questions.
Fair enough. At the same time, I think that doesn't change what I said. The spec is stable, so it should definitely get more interest than it does now. People should look at it. That's the point.
Yeah, fine. I'm just a bit, cautious. That's what I want to say.
Okay, fair enough. I think there was 5 questions.
Oh, you want more? I counted 6 questions in my notes.
Okay, my bad.
Yeah. Andrew, you have your hand up as well?
Yeah, I'd like to clarify. Like for Aragon, at least my understanding is that it's easiest for Aragon. So I'm not worried about Aragon implementing vertical trees. I'm worried about other clients because how I see it, like I don't understand how you can do it without moving to the data model with unhashed keys. Maybe I'm wrong, but I just don't get it. And it's the last time when I spoke to Peter, the Geth is not moving to Geth is still using hashed keys. So I just don't. Maybe Marius can comment. I just don't understand how Geth is going to implement vertical trees if they're not moving to unhashed keys.
So you need to rehash.
So where do you get pre-images from? Or you don't need pre-images?
Well, I mean, yes, you need to distribute the pre-images, but what happens is we're looking at a solution where only a smaller number of nodes. I mean, talk to Julio about it. He has worked on that topic. The idea is that some nodes that do have the pre-images, typically Aragon, will share the converted database with other nodes.
Okay, yeah, that's fine, but it's still like yeah. Again, my point is that for Aragon it's easy, but other clients should be happy with this plan.
Mm-hmm.
Yeah, to comment on that, I really I know that you can verify it and it's verifiable, etc., but I have an unease on this topic too, right? So I somewhat agree, but this is like maybe just a feeling that is wrong, but I'm uneasy about it as to get the state from one node, for example. But how verifiable is that? How easy verifiable is that?
Well, I mean, that would be very easily verifiable. You just have to check if your data can be reconstructed. But yeah, no, if I agree with you that this is not my favorite method either, but that seems the simplest at this point. Although I might change my tune in just a couple of days. Yeah, I'm actually lost. I lost the point of your question. Could you repeat your question? Sorry, Rakesh.
Wasn't really a question, just was a comment more. So.
Okay.
Yeah, that's relying on Aragon only to distribute the database is, yeah, concerning your, yeah.
We can do something like oh, sorry, go on. You're breaking up.
Yeah, we. No, we can't hear you at all, Dankrad.
It's the same.
What I was also thinking is that we can have a special small sub-protocol for just pre-images, we can implement it in Aragon, and then our other clients can just get the pre-images they want. But we need to test that.
Sure. Just to address another comment, so far, the best implementation we have is with Aragon. I never said it was only going to be Aragon that would do this. It makes sense that everybody tests, everybody tries to produce the same image and needs to verify that it matches.
So Nethermind is in the process of reworking its StateDB, and we have actually two streams. One like more more proven to work, and one very experimental. So I think we would be if we manage to ship it, and we can ship it this year. Question when this year. We might be able to do that migration more easily, but yeah, this is still an open question. We also, this more experimental layout, it's also done in this way that then later could be with a lot of changes applied to vertical trees. So it's called Paprika if anyone is interested, and it's direct storage of the Patricia Merkle tree on the disk using the memory mapped files in a way. So there are some good docs being produced by Shimon. So if someone wants to check it out, I encourage.
Thank you. Any other questions, thoughts on Rickle trees? Okay, I know, Guillaume, you said not to ask about this, but I'll try anyways. But I'm curious if, even if you don't have a full spec yet about the transition, like if you can share just a bit about your thinking about that and maybe like the trade-offs and yeah, just because we have plenty of time now to talk about vertical trees, so it's probably worth going over as much of it as we can.
Yeah, sure. I mean, once again, I'm about, like, we're having some results that are coming in that might make us change our plans. But so the idea is that indeed, because so far the translation was taking so much time, you have to rehash everything. That, I mean, except Aragon, that you have to do it offline. Like, you need some powerful machines to do it. And from our benchmarks so far, to be updated soon, it takes about 18 hours in the case of Aragon, and much longer for Geth to produce a conversion that then is sent all over to all the clients on the network. And well, more exactly, all the clients on the network download it, and they start replaying blocks on top of this conversion and catch up with the MPT head. and they have to do this before a given fork block. And at the fork block, the MPT is no longer updated, is jettisoned, and the Verkle state becomes the official state. So yeah, that's roughly the plan so far. We're having some yeah, okay, now I don't really want to talk about this yet because it sounds too good to be true. But yeah, the idea is that we would somehow be able to ensure that everybody is able to do their conversion themselves. But currently, with all confirmed benchmarks, this is not realistic. So we need to help, like some very powerful nodes need to help less powerful nodes to do the transition.
Got it. So and okay, and so at least I guess the thing I was worried about is the earlier specs of Verkle trees required like the network to stop producing blocks for a while or something like that. But with this spec, you would not have this issue, correct? Like you obviously you need to figure out the way to do it efficiently, but you're sort of swapping in the background from the Verkle the Merkle Patricia try to the Verkle try when the fork happens. But
yes.
Okay. Yeah. Got it.
Yeah, it has never really been seriously considered. It was more meant like a joke. Maybe that was a joke that was too catchy, but yeah.
But
no,
yeah, it wasn't clear that there was an easy way to do it without downtime, basically. And so I just wanted to make it clear that there is, or wouldn't necessarily call it easy, but there is a way to do it without downtime.
Yep.
Cool. Any other questions? Oh, there's a questions about do ZK EVMs make Verkle tries redundant? And I don't know, Guillaume Denkrat, do you want to take that?
I don't know if Denkrat is closer to a connection. My understanding is that yes, ZKVM, the long-term plan is to get rid of, like to replace Verkle trees with a ZK like construct. I don't think it will be made completely redundant because some of the choices we have are specifically designed to be ZK friendly. But yeah, that's just my understanding. I don't have, Denkrat should be able to answer that better.
Can you hear me now?
Kind of.
So yes, like a full ZK EVM that can, in a decentralized enough fashion, prove in like, say, a second that a block is correct, would indeed make Verkle trees like not necessary. But I think we are quite a few years from that. I'm willing to be proven wrong, but that is my current assumption that yes, like, I mean, ZK EVMs are coming, but like they still have much higher latencies. They also have massive prover costs. So I kind of have my doubts that they would currently get, say, a majority from the score, like say, oh, it's okay to just rely on them to know whether L1 blocks are valid. So far, I think we still need Verkle trees.
Got it. Any other questions on Verkle trees? Okay. Anything else anyone wanted to bring up? Okay, well, yeah, then I guess we can wrap up. So we'll move the self-destruct EIP to CFI. And I think, yeah, if in the next couple of weeks, people can review the stuff around EOF, the 4788 and the other beacon state proposals, and look at SSZ as well. We can continue those conversations on the next call. And the next call, I believe, will be right after Chapella. So yeah, last time, I guess this is a time for users to upgrade, and we'll go over how the fork went on the next one of these. Yeah, guess we can wrap up. Thanks everyone, and see you on the CL call next week.
Thank you.
Thank you.
Thank you.
Thank you.
Bye bye.
Thanks,
Thank
everyone.
you.
Thanks, bye.